variables, integrate. Okay? That's all. You're encouraged, right? We're encouraged, after I integrate both sides, to try to get as close as I can to solve for y. In this case, I couldn't actually solve for y, as I could in the previous. But sometimes I can. So I go as far as I can. Yes?
So if we're not able to factor out, when we start doing a problem, if we can't factor out the product part, then we use the other method. So otherwise we would do a first method.
If it's separable, right? I have a function of x times a function of y. Right? I just move this function of y over to the left side. And then integrate. And you're on your own there, right? As far as differential equations goes, when you've separated the variables, you're done with differential equations. Now it's just a matter of integrating. And I don't have any control over that. I mean, you either can or you can't. Yeah. I'm sorry, what? We're talking about separable equations. Is there another method?
I think he's asking, like, do you have to identify which route to take to the problem? Like, when you...
If you identify an equation as being linear, I show you how to do it. If you identify an equation as being separable, I show you how to do it. I've shown you. I've got more to say, but I mean, I basically showed you, right? Now, sometimes an equation is both linear and separable. And on the average, it's better to treat it as separable. Because linear involves that step of e to the integral p stuff. So on the average, if an equation is both, separable is usually easy. All right. So, so here's the first point. Here's an equation, it's separable. I separated the variables. I integrated. I get the general solution. That general solution typically is an implicit relation between x and y. Now you have to go back to calculus 1 and look up implicit functions and derivatives and that stuff. You got to know what it means to be an implicit relation. Okay. Now I didn't stop here. This is the general solution. That's true, but there's a preferable form. You try to solve your implicit relation for y. Now, of course you can say, well, hell with that. I'll just get my general solution and that'll be it. Well, but this is like a multiple choice question. So you're not free to pick what the answers are. You've got to match up your answer with our answers. And we attempt to express our answers with the implicit relation as close to solving for y as we can. Okay? So you'll have plenty of practice. Okay. Solution method. Establish that it's separable. Function of x times function of y. Divide both sides. See, we have y prime is, I forget what it was, p of x times h of y. Divide both sides by h of y to separate the variables. And then integrate. And here is the general solution. But it may not be in the best, in the preferable form. So you might have to operate on that then. Okay. So q of y will give equals c, general solution. This is typically an implicit relation. You may or may not be able to solve it for y. Generally, you can. Occasionally, you can. Now, there is a problem. When you divide through by this h of y, go back here. Where can I go? Let me see. Let me add a page right here. So we have dy dx is p of x, h of y, 1 over h of y, dy is p of x dx. This, of course, you're assuming, whether you realize it or not, that h of y is not 0. You can't divide by 0. So h of y has to be different from 0. So let me look at a quick example here. Y prime equals e to the 2x times, times y minus 1. I guess this will work. That's clearly separable. Function x, function y. Separate the variables. But, of course, we're saying y is not 1. Right? Y can't be 1. Can't divide by 0. All right. So, with that little caveat, as they say, we just integrate ln y minus 1, 1/2 e to the 2x plus c. Okay? Now, I'm interested in this function. I'm interested in the function y equals 1. If y is 1, what is y prime? 0, right? Root of 1 is 0. Okay. So now, where's my differential equation? Here's my differential equation. Does 0 equal e to the 2x times 1 minus 1? Right? I'm substituting y equal to 1, y prime equal to 0 into the differential equation. I'm checking to see whether y equal 1 satisfies the differential equation. And it does, right? This is 0. So y equal 1 is a solution. Now, is there any value that you can give to c which would have you conclude that y has to be 1? It turns out, actually, no. There's no number you can put here, right, which tells you that y has to be 1. So this is called a singular solution. Why did I do that? Because separable equations are a hell of a lot more complicated than linear. The complications are, one, that generally you just get an implicit relation for a solution, which you can't solve for y. And two, there may be solutions which are not included in the general solution. There's no value I can assign to c which will imply that y has to be 1. Now, I mentioned this back in chapter 1, and you can go back and look at the notes. Okay? So separable equations are actually quite complicated in terms of the theory of them. Your job is to be able to solve them. We're not going to worry about singular solutions. In my examples, I'll point them out, but you'll not be asked to find singular solutions. You'll only be asked to find the general solution. Okay. So, look at this thing. Whatever. Whoop. Okay. Well, you look at that. I can write this as what? 2x times y squared plus 4 over 4y, right? Which is, what? X times y squared plus 4 over 2y. which is function x times function y. So 2y over y squared plus 4 dy is x dx. I've separated the variables. Got all the y's on the left, all the x's on the right. Now I integrate. When you're practicing, you don't really have to write down. You know, you get the variables and then just put the integral sign. You don't have to write down two separate lines. You can if you want. So what is this? ln y squared plus 4. Right? 2y over y squared plus 4 is ln y squared plus 4. I set u equal to y squared plus 4. Du is 2y dy, so this is 1 over u du. Equal 1/2 x squared plus c. So there's the general solution. It's the general solution. Or y squared plus 4 e to the 1/2 x squared plus c, which is ce to the 1/2 x squared. I took the exponential of both sides. Remember, I'm trying to solve for y. All right, I better add a page here. So let me write it down again. Y squared plus 4 is ce to the 1/2 x squared. So y squared plus 4, sorry, y squared